For this video, we're going to continue in the same repository, the Java 01 working with data that we first referenced in the Java printing data video. So you'll want to go back to there if you need a refresher on how to retrieve the repository. But we did want to wrap up the discussion with this video, and so that you don't think that you can only perform operations on numerical data, we're going to look at performing operations on some other types of data. Now, while you can perform operations on strings, that's a very specific use case that's a little bit beyond the scope of what we're going to need. So we're going to look at a more simple example and look at Boolean data. So as we first looked at our data types, Booleans are only true and false values, but you can actually do a lot of operations with them. Not quite as many as with numerical data, but with a fair amount still. And so for this video, we're going to be focusing on Boolean operations, which are things you can do with true and false values. As before, we'll start by looking at a unary operator. And specifically, the one we'll look at is called the not operator. So if we start with a Boolean variable named a and give it the value true, we can run system.out.println a, and we will get the value true printed out. But what we can do is we can apply our unary operation, and instead of printing a, we can print the exclamation point, which you'll hear referred to as either bang, or you'll hear it just called not. And so what this line says is instead of printing a, we want to print not a. Well, if the only two possibilities are true and false, and a was true, then not a has to be false. And so not takes the opposite. And since there are only two possibilities, it's pretty easy to figure out. Now, if we wanted, we could capture b into a new variable and just say not a like that, and print b that way. And so that's a way we can do it. Or, just like we saw before with our number data, we can change the value of a this way by saying a equals not a, or a gets not a. So that's another way that we can change the data. And so those are some ways of working with the not operator. Now, if we are going with this approach, true gives us false when we take the inverse. So I said a was true, now it's false. If we were to change it and make it false initially, then it starts as false and turns to true. So all the not operator does is change true to false, or it can change false to true. So that's our unary operator that we look at when we're dealing with just one Boolean. But like number data, we can look at some binary operations as well. Now we can start looking at the binary operations that we're going to want to consider. So first we'll start by creating two Booleans. We'll just say that they're both true for now, and we'll change them as we see fit. And the first operations we're going to look at are called the AND operators. And AND is going to take two values and perform an operation that handles them like this. If both are true, then it's going to be true. Otherwise, it's going to be false. So AND means your two variables have to both be true for the whole thing to be true. And so if we want to say, okay, well, my result is going to be given by A and B. And so the symbol we use for AND is two ampersand symbols. And what it does is it says take the value in A, take the value in B, and perform the AND operation. And the AND operation is defined as we just said, where if both values are true, then the whole thing is true. Otherwise, it's going to be false. So if we run system.out.println on the result, we said that A is true and B is true, so the result will also be true. But if we make either of them false, so that now A is false and B is true, now if we run it, we get false. If we change it so that both of them are false, then we also get false. If we change it so that A is true and B is false, it's still false. The only way for it to be true is if both are true. So that's how we look at the AND operation. Now there's a more subtle AND called the bitwise AND, and it's going to look very similar. The only difference between bitwise AND the logical AND are that the bitwise AND only uses one ampersand, whereas logical AND will use both. But it behaves the same way in terms of the result it gives. And so you might be curious, why do we have two different ways of doing the same thing? Well, one thing you'll find in programming is that's very often that you'll have multiple ways of doing the same thing. But the other difference here is that these two operations are actually slightly different. Logical AND does something called a short circuit. And what that means is if it can figure out the answer by looking at the first Boolean, it's not even going to look at the second Boolean. And so for AND, that means if the first is false, the whole thing is false. So when we look at a case like this where A is false and B is true, the logical AND will never even look at B, because if A is false, then there's no possible way for the whole thing to be true, because for the AND operator, they both have to be true. Whereas for the bitwise AND, it can't short circuit. Which means even if A is false, it still has to look at B. And when you're working with simple values, like just true and false, that are simply put like this in these literal values, then they are going to appear to you as the programmer or the user to look exactly the same. However, when you start working with more complex data, as we'll see probably in a later video, this does lead to some subtle changes in behavior. In general, you should prefer the logical AND, but just know that the bitwise AND is a possible answer to any problem you might have, and that they both will perform very similarly, but that the logical AND does have that ability to short circuit. So again, both will only return true if both are true, otherwise they will be false. So the logical AND and the bitwise AND are two possible binary Boolean operations that you can perform. There is another binary operator that you'll commonly see with Boolean variables that we'll look at next. So we'll start with two variables, A and B, that are both true. And this operation is called OR. And just like we saw with AND, there's going to be two of these. So this is the logical OR. Just like with AND, it's going to take two values. And if at least one is true, then it's true. Otherwise, it'll be false. So if we want to capture the Boolean result of A or B, and we want to print that result, then we can do so like this. So these two vertical bars which you might sometimes hear called the pipe symbol. Two of those, each one is a pipe. So it's A, pipe, pipe, B, or A, vertical bar, B will give you the OR. And since A is true and B is true, the whole result is true. But if I change one of them to false, it's still true. If I change the other one to false, it's still true. But if both are false, then the whole thing will be false. And just like the logical AND, this operation can also short circuit. But it's different for OR. With AND, if either of them were false, you knew the whole thing would have to be false. So with the logical OR, it's if the first is true, then the whole thing is true, because it only requires one of them to be true. And so that's kind of what you're looking at with the logical OR. But we also have what is called the bitwise OR. And the bitwise OR, just like the bitwise AND, cannot short circuit, gives the same results. So we could say Boolean result equal a single pipe B, and we can run system.out.println result, and when they're both false, we get false, but if we change one of them to true, we get true. So again, just like with AND, we have a logical and a bitwise version. And bitwise is a little kind of ambiguous here. We'll talk probably more about what bitwise means in the next section. But just know that logical OR and bitwise OR behave very similarly to logical AND bitwise and that you should prefer whenever possible the logical OR and the logical AND. And so these are probably the two most common binary operations you'll see in terms of AND and OR, but just know that they'll break down into the logical AND, bitwise AND, logical OR, bitwise OR, and you should prefer the logical versions. The last operation we'll look at is called the exclusive OR. And this one behaves a little bit differently. One thing to note is that it is only a bitwise operation. You don't have a logical version of this. And the reason for that is because you can't short circuit this one. So again, we'll start with our Booleans. We have Boolean A equals true, Boolean B equals true, and we'll do our Boolean result equals A caret B. And that caret is representative of the exclusive OR. And instead of exclusive OR, sometimes you might hear it called XOR. And exclusive OR behaves similarly to OR. So with OR, if at least one of them was true, the whole thing was true. But with exclusive OR, we have exactly one true means it's true. Otherwise, it'll be false. So in this case, true XOR true actually returns false because they can't both be true if it's an exclusive OR. But if we change one of them to false, it doesn't matter which one, we'll get true. And if we change both of them to false, we'll get false because one of them has to be true. And the reason there's no short circuit version of this one is because you can't short circuit it. Because exactly one has to be true, it will always have to check both operations. So that's why this one doesn't have a logical version that can short circuit, but it does have the bitwise version. And the reason that the bitwise versions of these functions are important to know is maybe a little bit surprising, but you can actually treat things like ints, like if A is 4 and B is 7, you can actually get a Boolean result by taking the bitwise versions. So in this case, it looks like it doesn't like these, but it would like it if I give it an int. And if I were to do, we'll call this result 1, result 2, I can use that with the bitwise, and I can get result 3, and I can also do a bitwise there. So your bitwise operations can be used with ints to get integers, and let's see, out of curiosity, if it'll work with doubles. Okay, it doesn't look like it'll work with doubles. So I wasn't expecting it to. I just wanted to verify for myself there. But your integer types can use the bitwise operators in Java. Some other languages like C++, it's probably easy to use the bitwise operators with other data types if you do some bit magic there. But don't worry too much about what these operations actually do for the integers right now. If you look more closely at how these numbers are represented in the underlying data, the bits of the computer, then you can learn more about how these operators work on them. But for Booleans, they're going to be a little bit more straightforward. So just know that the bitwise operators can work on your integer types as well as Boolean types, but that the logical versions will only work on the Booleans. So if I were to try to use the logical AND here, it would say, hey, I can't do that. But just keep that in mind, that you have these operations that are meant for Booleans but can also work with integers. And if you're trying to learn more about the bitwise operations on integers rather than Booleans, consider how the numbers are represented in the computer, how the computer understands binary numbers.